Welcome to Moonshine Chemistry. We will proceed with property of cathode rays. Cathode ray from cathode travel in straight line and cast shadow of metallic object lays in their path. Means cathode is emitted from cathode electrodes. Okay, and this lay are actually travel in straight line and cast shadow of metallic object which are placed in their path. Cathode ray cause mechanical motions of small pinwheel placed in their path, hence they possess kinetic and must be material particles. Cathode ray, what they causes small pinwheels in their path and they possess kinetic energy and material particle. What cathode ray produce when strike the glass wall of discharge tube? Whenever cathode ray produce fluorescence, a glow when they strike the glass wall of discharge tube. In last video I already told you that cathode ray when strike on glass it produce fluorescence. Okay, then cathode ray when strike the metal foil it become red and start glowing. Now cathode rays when strike on metal become red and start glowing. Means that much cathode ray very strong. Okay, what cathode ray produce when strike on metallic surface? Cathode ray produce X-ray when they strike a metallic target. Whenever a cathode ray strike on metallic surface, X-ray is produced. Cathode rays are deflected by electric as well as magnetic field, indicating that they are minor particle streams carrying negative charge. Charge will produce gases ionization through which they travel. Now, cathode rays are easily deflected by electric and magnetic fields, which means that there is some charge minor particle in these rays. Okay, and means some negative charge would be there, and even it produce gas ionizations when they travel. Note, cathode ray produce depend on surface. Whatever cathode will produce will depend on surface. Cathode ray when strike on glass it will produce fluorescence, and when cathode ray strike on metallic surface X-ray will produce. Now this is a diagram, okay, and this is a design by Thomas method to determine charge to mass ratio of electron. Now J.J. Thomas had designed this experiment. Okay, so charge to mass ratio could be determined. Now same J.J. Thomson had studied cathode ray and through this he had discovered electron. Now why did he design this? Why did he design this, and how he determined ratio of electrical charge to mass ratio of electron, and what was the purpose of this experiment? Let us know further in this note. What J.J. Thomson, British physicist, measured by using designed cathode ray tube ratio of electrical charge electron to the mass of the cathode ray particle by using cathode ray tube is measured. J.J. Thomson, the same scientist who had designed discharge tube experiment, and he studied the cathode ray from that experiment, and he is the same person who had discovered the electron. Now he had designed this to determine the ratio of electrical charge to the mass of the cathode ray particle, okay, by using cathode ray tube. Okay, then what is application of electrical charge to the mass ratio of cathode ray Electrical and magnetic field perpendicular to each other to the ray of path. See, electrical and magnetic fields are perpendicular to each other ray of path. Note, ratio of electrical charge to the mass. ठीक है, ratio electrical charge to the mass. Now, particle deviation from their path in the presence of electric or magnetic field depend upon voltage applied across the electrode and opposing magnetic field. Now, particle deviation ठीक है from their path in presence of electric or magnetic field depend upon voltage applied across the electrode and opposing magnetic fields. Okay, deviation occur in presence of electric magnetic field. And opposite magnetic field strength. What happened to cathode ray in absence of electric and magnetic field? In absence of electric and magnetic field, cathode ray originates at cathode, pass through a hole in anode and strikes ZNS screen at Y. In this diagram, see, whenever cathode ray is in absence of electric and magnetic field, okay, they pass through a hole. See, this pass through a hole in anode and strike to the ZNS screen at Y. There is a ZNS screen and cathode ray emit from the cathode tube. It passed through the hole of anode and in presence of electromagnetic field it struck to the ZNS screen. Okay, this happened. It's travel in straight line because magnetic field and electrical field are absent. Now, fixed strength electric field is applied cathode ray are different towards positive electrode and strike the screen at X point. Now, when fixed electric field is applied to the cathode ray, okay, it will deflect it towards positive electrode and strike the screen at X point. Means when cathode ray emit from the cathode electrode in presence of electric field, this the path of the cathode ray will get deflected. It will not travel in straight line, but in that case it will get deflected because there is a presence of electrical field and strike at the X point. Then what happened to cathode ray when magnetic field is applied instead of electrical field? When magnetic field is applied, cathode rays are deflected towards positive electrode and strike the screen at the point X instead of applying electric field to the cathode ray at point X. See, when magnetic field is applied, okay, cathode ray will deflected from a straight path and go towards positive electrodes and strike at the X point instead of applying electric field to cathode ray at point X. Means when there was only electrical field, cathode rays deflected from the straight line strike at the X point. Similarly, when there was only magnetic field, then same cathode ray deflected from a straight line and strike at the X point. Now what happened to cathode ray when magnetic field applied at right angle? When magnetic field is applied at right angle to the electrical field, cathode ray are deviated in opposite direction and strike the screen Z. Whenever magnetic field is applied, okay, is applied in such a case that magnetic field should be right angle to the electrical field, and cathode ray will deviate from a straight line path and get struck to the screen Z. Okay, means magnetic field and electric field both are there, but they are right angle to each other. First, cathode ray are subjected to electrical field of appropriate voltage, so that cathode ray deviate from path and instead of at y on the screen strike at x. Okay, when only cathode ray, when only electrical field applied at on cathode ray, okay, and the electrical field of the appropriate voltage in certain way that cathode ray get deviated from a straight line path and strike at y on the screen instead of y on the screen strike at x. Means when electrical field is applied, uh, as usual it will strike at x instead of traveling a straight line y. Now along the electrical field, cathode ray are also subjected to, along with electrical field, cathode ray are also subjected to magnetic field strength H, so that effect due to electrical field is compensated by magnetic field, and cathode ray are once again brought back to the original point y. Now electrical field cathode ray are subjected to magnetic field. Means when magnetic field is there, okay, and is get affected due to electrical fields, which is compensated by magnetic field, and cathode ray will again brought back to original point y, the straight line. Now this is sound very tricky, and it takes much more time to understand it. Okay, so I will once again read this point. Okay, what happened to the cathode ray in absence of electrical field? In absence of electrical field and magnetic field, cathode ray originate at cathode, pass through a hole in cathode and strike at Z and S to the straight line. This is cathode, this is anode, okay, and as usual it going to the y point, okay. Then strand electrical field is applied, cathode ray are deflected towards positive electrode and strike screen at x points. In presence of electrical field, what happen? Cathode ray get deviated from its straight line path and go to x point, okay, positive electrode x point, okay. When magnetic field is applied, cathode ray are deflected towards positive electron and strike the screen at point X instead of applying electrical field. When magnetic field is there, then cathode ray get deviated from a straight line and strike at X point. Then when magnetic fields apply at right angle to the electrical field, cathode ray are deviated in opposite direction and strike screen Z. When magnetic field are at right angle to the electrical field, this cathode ray get deviated to Z. First cathode rays are okay. Okay, when magnetic field are only there, only present, it deflected to the x. When electrical field are there, it deflected to the x. Then when magnetic field is right angle to the electrical charge, electrical field, it get deflected to the z. And when both magnetic field and electrical field are there, means along with electrical cathodes are also subject to the cathode field of field strength, and so the electrical due to electrical field is compensated by magnetic field, and cathode ray are once again brought back to the original point y. That means both electrical field and magnetic fields are there, and again cathode ray travel to the straight line y. Now, by doing this experiment, J.J. Thomson had determined that ratio of electrical charge to the mass ratio value is 1.75820 10 raised to 11 charge per kg. Okay. M is charge of cathode ray particle and E is charge of particle M, Coulomb charge. The particles are negatively particles are negatively charged. Charge on the cathode ray is present as electron. Now particles are actually negatively charged, okay, and charged particles is represented as minus IE. So J.J. Thomson value of ratio of electrical charge to the mass for cathode ray particle was same irrespective of mass, gas nature used in the discharger, and material nature of which cathode was made. Now Sir J.J. Thomson determined the electrical charge to mass ratio for cathode ray particle used in discharge tube, material nature, and was made. This proved that all the constituent particle ray are identical. This has proved that the cathode ray have identical particle. This also proved that these particles are the universal constituent of all atoms of all matter, and means the particle which is in the cathode ray are identical and are negatively charged, and it is universally present. Okay, and it is the main fundamental particle of atom. Now what H.A. Lorentz had named this particle which is present in cathode ray and carrying electrical charge. H.A. Lorentz, who is a Dutch physicist, named the particle as electrons. Now charge on the particle. This I will explain you on next video.